almost identical to what we're doing in Surf Shell. Pull in OpenSRF.system as a dependency. Of course, you use Surf warnings. Bootstrap is still used as a verb because of bootstrap.conf, but in this case, we're going to call the OpenSRF core.xml file. We'll pass that as the first argument to the script, or you can just hard code it if you want. Create a session by using that session to create. You give it the service name that you want to create that session for. Issue a request against it. The same sort of arguments that we passed before. Gather gives us all the results at once. So if it's going to stream back results to us in piece by piece, Gather says, just give it all to me right now. So you won't use that if you're getting 1 million records back from the system, but if you know you're only going to get 5 or 6 journal responses, Gather is just fine. They'll put that into, this is a reference to an array. Because it's Perl, everything's a dollar sign. It's going to be a reference to an array. Disconnect from the session because it's always going to clean up. And then we just iterate over. Now, what you would actually do, this is a sort of a rough and ready way of showing you all the properties that exist. This is getting returned as it's just getting returned as a hash. This is going to be the disclaimer. Part of the problem with following this tutorial format is if you're following along in workshop.html, I'm building the basic, sort of started with a CGI script that did that call out to the Scholars Portal web interface and brought the data back and then was shown in a web page. Then I built this as sort of the first level, which did the same thing in OpenSRF, and just returned you the sort of raw hash or the list of hashes of those URLs and journal names, or sort of database names, is returning back. The next stage, where we cross the threshold from OpenSRF into Evergreen, is that Evergreen is object-aware and uses the interface definition language to define objects and their properties. So in Evergreen, you'd actually remove this, and well, you could iterate through the list of holdings, but instead of doing sort of the classic Perl keys and key value pairs with a hash, you would actually say holding and then your dash, angle bracket, target URL property as a getter. Or you can use it as a setter, go back and change that property. So we actually create objects based on their class names that get returned from calls when we cross the threshold in Evergreen. Right now we're still solidly in the OpenSRF side of the threshold. We don't know about objects at this point in the IDL, if you're following through the workshop. Yeah, this is beautiful. If you wanted to call this same service from JavaScript, and you want to go through the HTTP gateway, this is sort of a minimal approach to doing it using Dojo. Any fans of Dojo here? All right. Any fans of jQuery here? Yeah. That's not too bad, actually. There's only like one of each, so and that's actually surprising to see somebody like Dojo. It's good. I love Dojo from the perspective that it doesn't sort of get in your way and affect your namespace. It tries to stay out of your namespace as much as possible, so instead of just not JSON thing. But it's really handy for the to-JSON from JSON methods. Decode.js is actually implemented in FNGen. This is on the Evergreen side of the workshop tutorial, by the way. So at this point, we've defined the class in the IDL. We'll talk about that after. And we've run AutoGen because we run this thing called AutoGen, which is not the AutoGen that people from the AutoTools world know. It's something specific to Evergreen. It really needs to be renamed, which generates a list of 5,000 arrays, each of which represents a different class of the properties. And then this little puppy, which is JavaScript, goes through and creates object definitions for each one of those arrays. So we're generating 5,000 definitions for a single page request in JavaScript, which is a hell of a lot of overhead. And JSON tells us how to map that back and forth. Oh yeah, JSON v1.js gives us the decode.js function, which enables us to treat it as an object like you would in JavaScript object. So that's a whole lot of, it's seems like a whole lot, but this is actually the minimal example. If you look at the existing OPAC code for going through the gateway, you have dependencies on dependencies on dependencies that kind of get basically crying out for a flamethrower and a rewrite. But these things grow up. That's how they are. And until somebody actually has the time to sit down and do a kind of the ground up rethink and rewrite, deal with it as we can. So this is my way of giving you an alternative to pulling in 10 or 12 different JavaScript sets of things that are called utils, because everything is miscellaneous. Everything is utility. If it wasn't a utility, if it wasn't useful to us, we'd put it in a useless.js file and we'd keep it there and that would take control. The translator is pretty close to being the same sort of thing. This is just getting the raw data back from the translator, so again, we're back in OpenSRF threshold. But we could pull in, I think, field mapper would give us an auto-IDL Dojo server, and that would then give us the native objects. In this case, you can see we're just calling the property value rather than the object method on it. Same sort of idea though. Yeah. Before classic implementation of the IDL stuff. I better HTTP translator line. So this is a lot simpler. Just call Dojo. We bring in our auto IDL, which reads the IDL XML file, which we'll see in detail later. Dojo data, which shows that the data that's coming back, and field mapper, which maps the IDL objects to real objects here. And now we can do this nice thing. We're actually calling with the function. It's not so much necessary for read-only things, but it's actually really useful when you've got getters, setters involved. That's the main reason I care about that. And this request is a hell of a lot cleaner than that Dojo request.